Hi, in this video I'm going to be doing some of the exercises from the Rustlings repository. I will just do a few. Maybe they are too simple, but I'm not a Rust expert, so yeah, let's do it. Here I have the repository downloaded. I've installed it, and of course I had installed Rust as well previously. So at this point, we just need to run this Rustlings watch, and this program, which is contained in this repository, will just go through all the exercises, compiling them, executing them until the program finds a compilation error or an exercise that, as in this case, compiles at it is announced here, but the source code still has this comments line, and this will tell this program to stop and not move on to the next exercise. So this is the first exercise. Let's go open it. Maybe I can do it here. Let's move on to exercises intro 1. Here it is. So this program compiles, but it still has this command line here. So I will remove it, and this other program automatically will detect that the file has changed, recompile it. Since we have removed that command line, we will move on to the next exercise, which in this case is intro 2. So let's move on to intro 2, and let's see. Here are some errors from the linter or whatever, or the language server. I don't know. Anyways, and this one does have an error. Yeah, in this case, this expects some parameter because this is a formatting string or formatting. I don't know how it is called, but it will interpolate whatever parameters we put in here into these tokens here. So here we can follow the convention, just ignoring whether I'm not gonna discuss right now whether this is static memory or not static, or what kind of memory is this. I guess we'll see that later. So we can see this compiled, but still we have this command line here. So remove it and move on to the next one. Now it's variables 1. Make me compile, execute Rustlings. Okay, doesn't say anything. Okay, variables in Rust. Although we can infer, I think, the type of the variable from the initialization value, basically. You still have to say, put this keyword here, let x be 5, and this variable will automatically take the type, I don't know, integer or unsigned integer or whatever. I think we can also specify the type, be explicit about the type, and that's still okay. I'll remove it here because I will do the bare minimum to get it working, to get it compiling, basically. Let's move on to the next one. Variables 2. Let x, and if x equals 10. So we can see variable x is doesn't have a value, and it is used before we assign the value. So let's just assign it a value. We want it to be 10, or we want it to be not 10, but yeah. Okay, move on. Variables 3 probably, yeah. Okay. Of course, yeah, the output, as we know, the output from the Rust compiler is much more verbose than other compilers and for other languages. So for these simple programs, it's basically telling us what to do, more or less. So in this case, the variable x has a keyword let, has the type specified, but again, it is used before giving it a value. So it is uninitialized. So let's give value 10. Okay. And just curious if we can do x equal 10 here in the next line. Yeah, okay. So I like this better. So move on to the next one. Variables. There's 6 exercises here. So variables 4. Let x equal 3. It is, I'm gonna try not looking at the compiler output. So variable x is initialized, it's correctly defined, it is used here, so this will print number 3, x equal 5, yeah, then change this line. So here, the thing is that we are redefining, reassigning the this variable. And now if we consider we'll get the compiler output, then it's a good hint. So x is cannot be modified. But okay, what happened to this in the previous exercise? So in this case, okay, let's move on to the previous exercise. So x equal 10, still okay, x equal 11. Yeah. So you can only assign it once, unless it is mutable, right? Okay. So no, yeah. So let's go to variables 4. So since this has already a variable, we cannot assign it a different variable, because that would be the second time we assign a value there. So just make the variable mutable. Good. And move on to the next one, variables 5. Let number equal, this is string, print, that will print that, and number equals 3, and this is the exact, well, it's not the exact same error, because in this case, in the previous exercise, here, we were just assigning a different integer. So the compiler can infers the same type for this literal 3 as for this literal 5. But in this case, types are different. This is a string and this is an integer. So let's, so here if we look at the compiler output, it's expected string, basically, but it actually has an integer. So, I think we can redefine. And this is called shadowing or something like that, so that From now on, from this line on, the only number variable that we'll have is this one, not this one. And again, this new variable, which has the same name as this one, yeah, this one shadows this one. Move on to last variables exercise. Const. I know this one. Constants need to be assigned a type explicitly. So in this case, as we've seen before, the okay, so the way to assign a type is like that. Okay, move on to the next one. It is functions. Let's go to functions. One rs call me. There's no function call me. The compiler says not found in this scope. So fn call me with no arguments. That's it. Now it exists. It does nothing, but it compiles. Good. Functions 2. Yeah, here there is a syntax error. Here this colon must be followed by a type. So in this case, call me 3, which is an integer. So this is nice enough type to use here. Maybe we can use unsigned. Does this exist? Yeah. So okay, so that's it. And of course, this is a for loop. It will go from 0 to, I think in this case, 3 minus 1. So that interval's open on the right end. Yeah. Function main calls this function call me, but this function call me needs an argument. It's a parameter, so we have to pass it here. Let's do 10, just like before. Supply 0. So let's take a look. I didn't have time to look at the compiler output. Supply 0 arguments, so that's it. Yeah, 10. And move on to the next one. Functions 4. Main declares and initializes variable, and then it calls sale price with this parameter here. Okay, so there is a syntax error here. This syntax is used to clearly and specifically tell the compiler what is the output type for this function, not the output, the return type. So in this case, what is the return type? So this your sale price is something, so probably an integer. So this is returning an integer, the original price, and this function probably computes the sale price, applying some factor, whatever. So let's first specify the return type. And yeah, and now here there's another thing. I think this is called the tail expression, and it works even. Apparently, it works even if it's inside an if statement. A tail expression is that if you don't follow this with semicolon, and we will use it will use this value as the return value. Yeah. Same way if we say here 0. Oh, okay. I didn't like that. So just a little bit like this, and it will return price minus 10, price minus 3. In this case, 51, which is not even. It is odd, so the sales price is 51 minus 3, 48. Okay. Move on to the next one. Functions 5. Main, let answer equal square 3, and then it prints that answer. Square, and what does this function do? Okay, it squares this number. So 3 square types are specified correctly. Num times num, but here it is. This intends to be a tail expression, but it is not a tail expression because it has this semicolon here. If we remove the semicolon, yeah, that's it. And yeah, it is the last. It needs to be the last statement in the function. Yeah. Otherwise, it doesn't compile. Okay, and let's move on to the next one. I think, yeah, we change to a different category. We move on to a different category. So I think it's a good time to stop the video, and I will continue doing more exercises in another video. So thanks for watching. Bye.